My name's Rick Claus. I don't know if you've heard of me before. I'm the guy with the green hats. I'm a technical evangelist from Microsoft. I happen to have just recently moved my entire family, transplanted from Queen and Commonwealth up in Canada down to Redmond, the headquarters, the mothership of Microsoft. And I happen to focus and specialize in Windows Server and Windows System Center. I have a particular soft spot for storage. I love storage. So we're going to be doing this particular session around storage. Oh yeah, sorry, if you're into the Twitter side, MDC331 is the code. We were talking about this last night. It's a lot easier if you just put in hashtag #AUTechEd and just go with that. We filter that as well. So any comments, any suggestions, any ways to do things better, how we're doing, please feel free to tweet. I will respond when I'm off the stage because I can't tweet and be on the stage at the same time. Storage. Who here has storage? Everybody raise your hand. If you don't have your hand up, I don't know what you're doing in the room. You must be a client guy or something, because you have to have storage. And in fact, storage spaces actually exist on Windows tablets as well, in case you didn't know. You can do storage spaces with Windows RT devices, with Windows devices. Doesn't matter what you happen to have. It works all across the board. Some of the things that we are faced with as an industry, as a whole, massive amounts of data is being produced every single day, doubling and tripling and quadrupling your storage requirements. I like to equate it to the equivalent of my closet at home. I bought a new house, or I'm renting a new house in the States. I moved from a 2,100 square foot house in Canada down to a 4,100 square foot house. And I thought, there's no way we're going to fill this up. I've been there a year already, my closet is full. Just like your SANs are full of data right now. Tons of devices that are out there that are going off and basically consuming and absorbing this data, analyzing this data, a massive data explosion. And so basically, we're faced with the same problems you are as Microsoft running massive data centers, with the idea of running things like Azure and Bing, massive solutions and services up in the sky. They all require storage. All the way down into your private cloud environment, they have the same requirements. Storage, storage, storage. You need to have cost-effective hardware to be able to run your storage environments. Well, guess what, folks? There are no SANs in the cloud. You don't have a SAN on Azure. You don't have a SAN in AWS. You don't have a SAN in Google. It's too expensive. Cost per IOPS is way too cost prohibitive to be able to extend it. Who here has more than one SAN in their environment right now? Almost everybody in the room. Isn't that fun? Managing 2 different SANs, 3 SANs, 5 SANs, then throw in different manufacturers, and then you're just absolutely screwed. You're trying to have some level of consistency. You have to have some kind of way of looking after resiliency on that storage, some way of managing that storage. You have to eliminate multiple points of failure on that storage to make it more resilient. And it's the operational cost, keeping those things running. So the capital investment's a big thing, but keeping them running and managing them effectively, that's where the cost actually comes into for storage. I like to equate it to like the black art of storage. It's like, it's a special course you have to take at Hogwarts. So I thought, first of all, I did this a little bit inside the introduction session. Demystifying your storage appliance. What exactly is a SAN, a storage environment? Well, there's obviously a number of different manufacturers, but basically it all comes down to a couple of things. You got your compute power, which is running on top of x86 or x64 processors. You've got memory to be able to handle cache in the operating system and different things along those lines. You also have, obviously, network adapters that your clients are going to be attaching themselves into to be able to access those resources. You got to plan out that network and how that all works. And you also obviously have some way of talking to your storage, like storage HBAs or something like that. Pretty simple stuff, right? Well, when you put it all together, it actually looks like this. You got yourself your storage controller. The controller has a front end and a back end. On the back end, you're going to have your access to your physical disk that's attached inside the chassis, inside the arrays. You're going to have different pools of disks, different ways of doing stuff. You're going to have LUNs. You're going to have the ability to go through and lay down data protection in a variety of different formats. Each manufacturer has their own way of putting the data across those drives for their best solution. And then they're obviously talking to a variety of different types of shared SAS drives. Then you've got the front end, which is going to go off and present this storage to your clients in some way, shape, or form. And that's going to be through an iSCSI target. That's going to be through fiber channel over Ethernet, NFS, SMB. You choose the protocol of the day that you want to use. Each manufacturer implements their own version of that, by the way. If you want to make it highly available, oh, there you go. Double it up. Get a second version of that same thing in there. Now talking shared SAS to the disks as well. And then finally, you've got your clients being servers going in and talking to those presented LUNs and resources and everything else like that. Wow, pretty complex. Don't blink. Server 2012 R2? Well, Did you see that? Let me go back, and then forward, and then back, and then forward. It's the same architecture. The difference is our back end is Server 2012 spaces. Our front end is Server 2012 file server, scale-up file server to be exact. And that presents that in common industry standard protocols to the clients, which are servers. And you can have 2, 3, 4, 5, 6, 7, 8, 9 different amount of scale-up file servers that are out there. And you can obviously use different types of networking protocols to be able to go off and talk to them. Now, our vision is basically, what can we do to try to eliminate and lower the costs that you guys have to shell out to be able to use these storage and resources? And we're bringing our technologies that we've developed for the public cloud and bringing them into a private cloud implementation with Server 2012 R2. And we're doing it as a way of trying to drive down cost of infrastructure as a service. You guys provide infrastructure as a service to your customers internally. We're also trying to disaggregate compute and storage to have this scalable notion of being able to grow one or the other as you need to. If your performance is the bottleneck potentially on a Server 2012 implementation, you simply add in another node on your cluster. Done. The main thing is also that we're using industry standard servers, networking, and storage gears. There's no proprietary Microsoft mumbo jumbo going on inside of this. It's all available to be used. And you can have a variety of clients to go up and talk to it and use it. Inexpensive networks. You get what you pay for. Inexpensive industry standard JBOD. JBOD stands for just a bunch of disks. So our deployment model for how to get this out, well, pretty simple. Traditional side, Windows Server file cluster side of things with storage spaces, you basically configure the bottom half. Configure your shelves of your drives, you have the proper interconnects, you build in the level of resiliency you can afford and that you want. You build up the level of scale that you want to have. On the fiber channel side and on the SAN side of things, you still got to be able to do that. On the server side of things, I'll show you how to do that today. And then you simply, using the protocol of choice, in our case, we use file level stuff with SMB3. SMB3 is actually incrementally improved in the version for 2012 R2 release. And in case you didn't know, we're actually making SMB3 obviously available. We're working with the industry so other people can implement their own SMB3 protocol front ends as well. So again, it's not just us. And then you have your Hyper-V nodes that go off and talk to this. So if I'm looking at this from an abstraction perspective, I've just abstracted one of the most expensive pieces of your networking infrastructure, of your current infrastructure for your systems, your storage. The real beauty of this becomes when you have to go off and expand upon it. Buy another JBOD. Plug in the proper SAS cables. You just now have 60 new drives to be able to add into it. Need some more? Maybe you build in a second scale-up file server cluster. You then abstract the namespace so your customers don't even know that you're on a second cluster. You can do that sort of stuff very, very simply. Any questions? You guys still awake out there? You're very quiet. Okay, there's a couple of people. If you ask a good question, I got 6 maple syrups from Canada up there available in 2 sizes. 1 ounce for the discerning gentleman that wants to simply share and show it off in the windowsill, and then 2 ounces for those of us that actually want to eat it. Because of this architecture, when we were planning and proposing this, we actually met and talked with a bunch of these people that are known as original device manufacturers, ODMs. You probably haven't heard too much about those. They started to come more to light last year. You may have seen articles in the news about a year and change ago about different online cloud organizations. Starts with G, ends in E. that goes off, and they basically have custom-made servers to be able to do stuff in their data center. Same thing with Amazon, same thing with Microsoft. We don't buy them from off-the-shelf OEM manufacturers. We buy them from ODM manufacturers that design them just for us and for our data centers, potentially. Well, we came up and suggested an architecture to be able to create something called a cluster in a box. The idea of literally a single piece of tin that has 2 nodes with no backplane that you would expect to be able to see, like in a blade chassis, but literally 2 independent nodes. You can pull one node out, it continues to function, replace the node, and it just keeps on working. Between them, they have an interconnect for Ethernet to be able to have heartbeat and communication between both of them, standard everyday NIC that goes on. You have some kind of a storage controller. Maybe it supports spaces. Maybe it doesn't. I actually have 2 different systems in my lab environment right now. One of them is a data on device, and that one there is using storage spaces, built-in controller, built-in hard drives. The second system that I have is one by Quanta, and I'm using an LSI Synchro hardware-based RAID card that does the same thing. So you have a choice. Inside that, you then simply have a connection to a SAS expander that has access to disks. Can be inside the box, like mine are, can be outside the box with external JBOD connections. You get into this new architectural building block for your different solutions if you wanted to. There's an example of what the data on one looks like, the DNS 9220, dataonstorage.com if you're interested. Think about having to go off and expand your storage. I can put 3 terabyte drives inside the front of those guys, times 12, 36 terabytes in one unit. They boot off a little SSDs on the actual nodes themselves as an example. You could plug in an external drive chassis onto that, have an additional 63 terabyte drives, and I can't do the math that high, that you could then expand your storage array into. This is perfect for like the mid-size, for the branch office, for the office in a box concept, if you will. You can go off and drop and deploy these things, or you can use them as building blocks within your own private cloud to do different things. So our storage spaces sounds great. Some of you that have been around the industry for a while, you guys remember that slide, NT31, NT351 from the keynote? I was there. I was certified in 351. Software-based RAID's been around for a while. Storage spaces is not software-based RAID, doing a mirrored disk and a RAID disk and that sort of stuff, and having to go into Disk Mangler to go off and change things. It's not that at all. If you look at your traditional storage environment, okay, what do they have? Well, they have storage tiering. They have data deduplication. They have RAID resiliency groups for protection of your data. RAID 0, RAID 1, RAID 5, RAID 10, RAID 6, RAID whatever. They have pooling of disks that are taking place to pool together characteristics. They have high availability built in from having multiple nodes. They have write-back cache to protect you against drive failure. They have copy offload with blah, 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 blah. What is that? ODX, thank you. Phenomenal session from EMC last night. I popped my head in to watch that one there about ODX. Man, that's fast. That's awesome. And then snapshots as well. Well, guess what? Windows Server 2012 and 2012 R2 in particular, 2012 R2 introduces some new stuff. We had it already brought out and used in 2012. I know some people are using it now. With 2012 R2, you now have storage tiering that's possible. I'll show you some really cool demos with storage tiering and how that works. Data deduplication, greatly enhanced with R2, and also improving performance with it. Some new resiliency options. Besides simply having mirrored and parity, you also now have parity to support multiple drive failures. Pooling of disks existed, continuous availability existed. Ben Armstrong was talking about how if you have Hyper-V clusters talking to an SMB file share that is highly available and protected with scale-out file server, one node of that file share can go down. The Hyper-V boxes don't know. They don't care. They keep on running. That's awesome. Persistent write-back cache in case you don't have battery backup on your controller cards to be able to protect those data loss for writes. I'll show you that as well. SMB copy offload and also snapshots. So basically, we also support hardware acceleration for moving stuff around. What's the difference between these guys? Say it louder. Dollars, costs, expansion possibilities, reduced cost in management, reduced cost of implementation. Cost is a big, big difference. So this tiering piece is probably the coolest thing that I've seen brought into storage spaces. I was very excited when I saw it. I'm going to do this as one of my very first demos. I mean, think about this from a cost and performance idea. You've got 60 drives in a JBOD. You're getting OK performance, what you want to have, 1,000 IOPS, 1,200 IOPS, 1,700 IOPS, whatever it happens to be. Your Exchange admin, your database admin from SQL, whoever, has gone through and basically asked you, look, I need to have more performance on my disk, my minimum spec. Because you know how people implement projects, they always tell you the hardware specs they want to have, not by size, but the actual stuff you need to know, like how many IOPS the thing is going to have, what type of read access does it require. In an environment where you have 60 drives in a JBOD, I got this question earlier on, how many SSDs should I add into this? Something as simple as anywhere between 4 to 12 SSDs inside of a 60-drive JBOD is an optimal amount of cost dollar value versus density of how much data you can store inside of it to get the best performance. If you go higher with the number of SSDs, you just simply end up costing more because the SSDs are expensive, and you're reducing your overall capacity for what's inside of it. Another thing that we were asking is that we basically go through and we are able to go and monitor what's going on the drives for access by the system. And we're able to determine on chunks how much of those different chunks are hot, how much of them are cold. And we'll move the hot chunks over to the SSDs, increasing performance. And then when they become cold again, they'll be moved back over to the drives. Before anyone asks, because no one's asked me yet, and there's maple syrup on the line over there. These chunks are in 1 meg chunks, in case you're wondering, but size-wise. And it happens at a scheduled basis. There's basically a scheduled task, which I'll show you, that runs and basically analyzes the data and access. And then there's another scheduled task that runs after that analysis is done and moves the stuff. And that currently runs at 1 a.m. in the morning. You can manually trigger it with PowerShell. You can change the schedule if you want to happen to your own workloads, work areas. You can run it multiple times during the day. I'm actually going to be doing something where I'm going to be pinning and moving stuff on the spot. I just realized that my screensaver kicked in. Before I have to jump to a demo, I'm going to unlock my system. There we go. Basically, you can run it more frequently if you want, or you can change the times, or you can run it manually if you want to. There's also a post-optimization report that comes out with the PowerShell. If you do it through PowerShell, you can only do it through PowerShell. It'll tell you how much data has moved. Is it ready to go? Is it not ready to go? I just realized that my demos are actually a little bit backwards. I've got my write-back cache demo first, and then I've got my tiering. So I'm actually going to hold off on the demo. It's a little bit longer until I talk about this thing called write-back cache that's coming up. So who's been some of our proof points, dog fooding-wise? Well, we have this team. I don't know if you've heard of them. The Windows team. They have a massive amount of code that they manage, and bug checks against the code, and revisions of the code, and releases, and symbols that go along with it. They generate an inordinate amount of massive data that needs to be shared amongst the entire Windows team to be able to reproduce errors and recompile, that sort of stuff. So basically, every single team that works on the Windows team, all sub-teams, all need to have their own ways of storing stuff. And in the past, it was all siloed inside these different SAN environments that were inside Microsoft. So let's just say that they have an awful lot of data that they have to worry about working with. So in their current environment right now, they have about 2 petabytes of data that they had, and they basically only had enough space in all their SAN arrays to store 5 days worth of version information off of those 2 petabytes that they happen to have. So they said, you know what? Well, the daily builds guys, we want to have more data to be able to go off and take a look at different versions, stuff like that. We need to expand our SAN environment. And basically, they needed to look at what's it going to cost to be able to grow that from 5 days to more. So now they have even more SANs and more direct attached storage, people get it to work. So it gets rather complex to also worry about deployment between all these different things for having access to them all. So they wanted to change from 5 days to 30 days worth of data to save. And they also need to go off and scale it in the future, because guess what? We're not stopping developing the development of Windows. We keep on rolling, baby. Keep on rolling. So basically, we're now going up to a month of data. We want to also lower our costs, and we also want to have some kind of a platform in the future. So we're working with them on this file services team to be able to go off and to come up with a better solution. Storage spaces was it. So they implemented a storage spaces solution, architected correctly, and we're looking at basically a 2 times increase in overall throughput coming through it. It actually came to the point where the network was the saturation link to be able to get access to the data. And it actually bled across buildings because the team is not all in one building. So basically, they need to update all the switching infrastructure to be able to accommodate all the massive amounts of data that's being moved around every single day. There's a 3 times increase in capacity for the exact same budget because we're no longer buying the proprietary SAN hardware to be able to do this. So we went down to approximately, number-wise for the budget, we went from $1,300 per terabyte of storage down to $450 per terabyte of storage on the system. We got a 5 times increase in capacity because of deduplication and also now being available across the different systems, which basically meant that we could save, instead of just 5 days worth of data, 30+ days worth of data on this new environment. And then also, think of the power. We reduced it from taking down 120 servers down to only 20 servers. We pulled 8 full 42U racks of gear from the data centers and replaced it with the new implementation of the storage spaces and how that works. That's incredible. That's huge. No more power, no more cooling, no more space on those data centers. So basically 20 servers with 20 60-bay JBODs for spaces. They're all interconnected with 10 gig E. Again, this is properly architected. Yes, it's still going to be expensive, but it's still a fraction of the cost of what the other implementations would be. It's connected up to your other buildings on campus through a big meshed aggregate network that happens to be in place. During the Windows development process, picture this, 720 petabytes weekly of data volume was flowing through this network in this space. That's blowing. That's just, oof. It's one of those things. Absolutely nuts. So that's a pretty, let's just say they're happy. Because to expand upon it, we can easily go ahead and just double the deployment over the next year. 20 more servers, some more JBODs. We're all set. We've aggregated the namespace into a seamless vision of the namespace that's out there. So, storage spaces. What are the components for how this works? We keep on saying this word, standard storage hardware. You can call it commodity, basically cost-effective hardware. It's a JBOD enclosure. Shared SAS JBOD arrays, enterprise-grade redundancy. Again, you don't want to go down to, what do you guys call it here? Dick Smith's, and just pick up a NAS device? No. This is still, I'm sure Dick Smith's is quite good. This is still an environment where you want to go up and get enterprise-grade redundancy that's out there. You need to have some dual-port SAS drives that are on those systems that are plugged in, wide variety of form factors that are there. You basically have multiple physical disks that are together inside your shared SAS JBOD. You pool those guys together into a pool, PowerShell or via the GUI interface if you wanted to. You have the ability to go in and to implement resilient storage spaces on a variety of different ways. Maybe some of them are going to be striped. Maybe some of them are going to, parity, sorry. Some of them are going to be mirrored. You have the ability to go through with striping or with parity spaces to protect it and basically create your protection level. The neat thing about this is that when you're creating these individual spaces, they are enclosure aware, and they will actually spread the data across multiple enclosures to minimize your risk in case one enclosure goes down. Very cool. If one drive goes down, in case you don't know, there's actually a command where you can say blink the light, and you can actually find it inside the tray of drives. When it goes down, the neat thing about this is because we aren't doing this at the disk by disk level, we're doing this at the slab level across the different drives, we can do parallel rebuilds on that missing drive, virtually eliminating the need to have hot spares. In a lab environment, if you had 8 3-terabyte disks inside your environment, one disk fails with about 2.4 terabytes worth of data on it. If your bottleneck's a single drive to rebuild that, it's going to take forever. Because we can parallel rebuild this across the different systems, you're looking at 48 minutes to rebuild that one down drive, or about 800 megabytes per second for the system, way beyond a single drive going down. We have this thing called a data integrity scanner, both an NTFS and our EFS, that basically rebuilds bad data whenever possible. It's also manageable with PowerShell, does periodic scans, autocorrects where possible. You're able to go off and manage it with PowerShell, with Server Manager, with System Center Virtual Machine Manager 2012 R2. You also have the ability to implement these things called continuous availability with file server clusters, which is the obvious architectural way you want to go. Some recommendations. Well, people always ask me, well, what kind of drive should I configure for my resiliency here? Well, Mirror basically is the best bang for the buck across all workloads as your generic way of doing things. It's your best level of protection. It is also the quote-unquote most expensive as far as having to have more disks to get your capacity. But you can do basically a two-way mirror or a three-way mirror, and there's 2 or 3 copies of that data across all the drives that are involved in that space. Parity, you can go with single parity or new dual parity with three ways of the data going across. That's really good for sequential stuff or archival stuff you want to have protected. Simple, all that is for speed. Lose the drive, lose the contents, just like you would expect. So there's no resiliency. You have to provide some other way of getting some resiliency on there. So some examples as how you would look at this. In this case, you've got shared SAS JBOD arrays that are set up, and you've got interconnects of 8 SAS connections into those JBODs, because you've got 2 per JBOD plus also 2 per server. You've got mirrored spaces that have been set up with your storage pool and storage spaces. You then have a unified namespace, all because you're using clustered shared volumes. So you can basically just have one share name and then put in the different volumes that happen to be in there. The CSV basically will aggregate your namespace, and then you present it as a share. Once it's presented as a share, whatever you want attaches up to it. This is something you might not know. Clustered shared volumes with the scale-out file server is not what you would use for your Office documents, for your data shares. It's for a workload. It's for the virtual machine VHDX files. It's for your SQL Server 2012 databases and stuff like that. It's not for your file shares with your accounting data and your home directories and stuff like that. Use a traditional file share on this. Don't use the scale-out file server on this. So when you actually make a scale-out file server, it'll ask you what type of share you want to have. But basically, it's very similar to a traditional storage deployment that you would next see. Scaling this out, going from 96 gigabits per second of shared SAS links, you're now up to 4-way across the board. So you're up to 786 gigabits shared access. So now you're getting into the big dollars here. I mean, you have to have, again, multiple connections, redundant of SAS connections into each of those JBODs from each of the servers. All the servers have to have access to all the JBODs with multiple paths. This is now when you're getting into the shared SAS switching environment, different types of spaces, same kind of thing. Now, picture yourself one more level in, where you actually now can have groups of those chunks of scale-out file servers together, and then you aggregate the namespace still. You're looking at close to, if you have 60 bay drives with 3 terabyte drives in them, almost a petabyte of storage per implementation. How do you manage all this, guys? System Center is the correct answer. You could do it with PowerShell. There is a PowerShell MVP in the room that could probably do it for you, available for hire. You can also do it through Server Manager. But when you get to this kind of size, obviously, you're looking at automation. System Center is the way to go. SCVMM fully supports being able to manage, deploy, scale out, and build the stuff with the file servers. Question comes up, what about performance and performance analysis? And yes, there are performance and performance analysis information available, all exposed through perfmon. The counters are there. Optimally, you'll be doing that kind of stuff through System Center Operations Manager components to be able to tell you the health of the drives, how things are going, that sort of stuff. Interesting quote from a customer: by using storage spaces, Hyper-V over SMB, and other new features, I've eliminated big, lumpy capital expenditures. I love that. I can buy inexpensive storage, buy only what I need for the project, and then scale in a completely linear manner. There is no bottling off and trailing off at this point. provided you have the architecture behind it to support it. The Windows team, senior developer for the Windows team, we're able to use the commodity hardware to achieve the same functionality of traditional storage at a far, far lower cost that's out there. So finally, we've done the architecture, we've done the discussion for how it all works, concept-wise. Let me actually show you a bit about what's inside Storage Space's capabilities with R2 and how it works. Traditional marketing thing that you have up here, basically we're trying to obviously go through and minimize your overall spend, reduce your overall outbound expenses with capital expenditures. We're trying to maximize your dollars per IOPS. Dollars per IOPS is the measure, basically, of how efficient your storage is running based on the cost. You implement continuous availability with some kind of a clustering involved, and then also you have to go through and have some minimized amount of operational management. Think about that. If you had to expand your storage array and you ended up with a different version from the same manufacturer, different management interface potentially you have to work with. Go with a different manufacturer because they run the lowest bid, completely different interface. There's no standards between them for how to manage them. So, one thing you can do, this thing called dual parity. The idea of providing resiliency to two possible disk failures across your systems while minimizing your space that's being used for that level of resiliency. It's got very efficient rebuild times. Dual parity basically protects you beyond a single disk failure in your environment. You've got both single parity and dual parity available. Things that we do is kind of neat, basically. It's this thing called integrated journaling, where we take the changes in metadata on a dual parity space and basically protect it and make sure that it's consistent to be able to find it. So when there happens to be an issue with not having a dedicated battery backup for your writes off your controller cards anymore, we still have the ability to bring back those changes because we have the persistent storage. The way we achieve that is through write-back cache, and we actually borrow some space on your SSDs to be able to do that. Matching your workload across your drives is kind of interesting. So say you've got a couple of terabytes worth of data, a couple of petabytes worth of data that's going off there. You've done up the storage spaces because you just left this talk. You've gone back, you've bought 4 SSDs, maybe you talked to the XIO guys, and you got a couple of those really cool looking accelerator cards that use memory to be able to do this. You got a very large data set. The bulk of that data set is probably going to be cold, if you will, not being used. That's going to sit on your cheapest, largest disks inside your environment that you can afford to put inside your storage array. A very small minority of that data is what actually is being used, and that's basically what's known as the hot data on the working set that gets changing. Because the neat thing is this hot data doesn't always work. So you might be tempted to go in and to pin a file to the hot tier and leave it there. But you potentially are going to be doing yourself a disservice because it may become cold and it's just wasting space on your fast tier. Let the optimization engines do their job, because what happens is your data set changes over time and slightly moves potentially. If you've pinned a file, you have to unpin it to be able to get it off of that tier. Let the system do its work to be able to get that done. Some characteristics which is rather interesting. People were asking me, first of all, can you do tiering with different speed of drive rotation, RPMs, with our solution? The answer is no. We've basically done the math and done the work and that sort of stuff to basically determine that you're not getting much of an advantage of IOPS per dollar by investing in faster drives. You're basically reducing your capacity. If you go 15,000 RPM drives, maybe 300 gig drive, you're spending almost as much as an SSD at that point. You might as well just go for the SSD and get better throughput. Also, in case you don't know, a 15,000 RPM drive consumes 5 times the power of a 7,200 RPM drive. So it's going to drive your power cost up, especially when you're talking of hundreds of those drives over time. Solid-state drives basically give you your best dollars per IOPS. 7,200 RPM drives gives you the best capacity to be able to get more density inside your storage array. So your tiered storage is the best way to get your maximum IOPS. Basically, it's a mix of traditional hard drives inside your shared SAS JBODs and SSDs inside your environment. It gives you the best balance between capacity and your performance. And as I mentioned, you can basically pin stuff to the hot tier or to the cold tier. This last piece I want to show you here is this concept of write-back cache. So say you've gone ahead and you've got your stuff all set up, you've got spaces working, you've got tiering, it's absolutely fantastic, everything's going great for your performance, and then all of a sudden some of the administrators that are on your systems, they realize they've got this great performance, they're doing stuff with reporting, with databases, it's all chugging along, and then all of a sudden for some reason at noon on Tuesday, a massive spike in performance happens and your IOPS per second tanks. Because you've changed from sequential reads to random reads, you've moved the heads around, and basically your performance sucks for that period of when that job is run. And then it's fine again. And then maybe next Friday at noon, it happens again, boof, down. Everything crawls to a stop. That's basically the issue of having I/O that is out of the characteristics of what is currently taking place in your system that needs to now be adjusted. So we have this thing called write-back cache integrated. When you create a storage space tier, when you turn on write-back cache, we remove a portion of the total storage of that tier away from the hot data, and we reserve it for our write-back cache. It's consistent across the drives. If for some reason you have a failure of one of your scale-out file server nodes while activity is happening, and it was on the memory controller of that particular controller card, and it moves to the other one, what happens to the stuff that's on that cache on a traditional environment that's battery backed up on the controller? You lose it. You're now no longer consistent. You got problems, and things have to happen to get replayed and stuff like that on the other side. We actually, again, because it's stored with the drives, the other node takes it over, it's there, and it can basically access it again. So I don't know about you, but for the last day of TechEd, and being the first session in the morning, you have been extremely patient listening to me talk without having a demo. So I think it's about time for a demo. Would you like to see a demo? Everybody out there? Okay, you're still awake. That's the good thing. Now, I've been talking so long, I'm hoping it's number 5. Yes, I got the right switch. Let me show you this. So I'm basically remoted back into my lab in Redmond. And in Redmond, I happen to have 2 cluster-in-a-box devices, one by Data On, one by Quanta. They have 12 drives in the front. This particular box I'm into right now is the one by Data On, and if I take a look at it at the hardware level, zoom it works really slow, just so you know, over top of an RDP connection. There we go. So I've got 4 SSDs that are running that are 186 gig in size, call them 200. And then I got 3 terabyte drives that are 7200 terabyte drives as well for some density. So they're basically set up. All you do to create a pool, highlight them all, new pool, done. And then you go and you lay down your protection level of different sort of stuff. So we've gone ahead and already created a pool and already created a couple of virtual disks. And we've got on a per disk basis, you enable write-back cache. So I've got write-back cache turned on for one of them. I've got no write-back cache in the other one, and I've got something else going on with some tiering stuff. A colleague of mine on the file server team basically came up with this great way of being able to demonstrate this, and he even made a PowerShell script to make sure I don't fat finger anything. So this is it. This is awesome. I love the ASCII art. Write-back cache demo. Press enter to start the demo. What we're going to do basically is we're going to go in and run a workload against this, SQL I/O. And it's being run simultaneously on both of these different tiers, or both of these different virtual disks. And you can see here that the blue line is giving us consistency that I'm getting, just under, somewhere between 500 and 600 IOPS that are going place on that workload. Blue is good. That's the workload that's running, that's making your company money, that's making your people happy, making you happy. Everything's all good. But then randomly, someone that also has access to those drives has gone ahead and done a different workload that's non-characteristic and creates a spike. If you look really closely on the screen, you'll see that there is a red dotted line that jumped up on the one with write-back cache. That's the extra workload. What happened to the blue line on that side? Kept on going, didn't even notice. Whereas on this guy, which is the without, the blue line kind of went, don't know what to do. Let's just say that we have a bunch of spikes that starts to happen. Your system gets hammered. Something's going on. Maybe they're playing Minecraft or something on the server. I don't know. How does it work? Would you rather have the system on the left or the system on the right? You can answer. I would take the left one personally, and I'd also find out which admin is running those workloads and go kick his butt. But effectively, my performance is not affected by that extra work that's going on. That's write-back cache. It literally is something as simple as having 4 SSD, enterprise-grade SSDs inside my drive array of JBODs, 8 regular 3 terabyte drives inside there as well. Create a pool, say turn on write-back cache, done, finished. Commodity hardware out of the box. I think that's cool, eh? You can give me a little bit of love here. Now, if you stay tuned, don't run away. I'm going to jump this session level up from a 300 to a 500 at the end, because I'm going to be showing you 175 lines of PowerShell for you to be able to reproduce this kind of demo in your own environment. Very simple stuff. And you can, if you want to, you don't have to rewrite it, and there's a great blog post that goes along with it. We're basically now going to queue this up into the tiering side of things. So people like say, okay, I don't understand this tiering thing. Just how kind of good performance is this? So exact same drive configuration you saw before. And this time the drive configuration is set up for another workload that's going to be going on in this particular session here. So I'm just kind of cleaning this up. The PowerShell is going in the back end. It's flushing the caches and everything else. And this time we're going to show you the tier in effect. So picture this. Not using the SSDs. We have a drive that's going on, SQL I/O loads going on this guy with this particular drive array with 8 drives that are being used. They're all spindle-based. I'm getting about 1,100 IOPS per second. Yeah, it's pretty good. It works great. But then my CFO comes over and says, you know what? I need to have more IOPS for my accounting software, because the CFO always comes to you to ask for more IOPS, I'm sure. And I now need to go off and to make it so that I can get better performance. And he says, okay, here's the checkbook. Here's $1.6 million to go off and buy another SAN. Let's go and do this. And you say, no, no, sir. No, no, ma'am. We don't need to do that. Let's just go off and buy some SSDs from Dick Smith's and pop it in the servers, and you're all set. I got it. Is there a Dick Smith's here in the Gold Coast? Like, there is one? I want to go off and see them. I want to see what their prices are like. Pardon me? We'll go Saturday. I'm sleeping in Saturday, though. So all you do, literally, is with your existing system, you pull some drives, you take them out, you put the new drives in, you include them into the pool. You now have 4 SSDs inside this environment. You want to have better throughput. Well, you simply go in and you enable tiering on that tier. So let's go and move our workload. This would normally happen as is determined if you turn it on through the optimizer at 1 a.m. I'm pretty sure no one wants to be here at 1 a.m. So we're going to do this manually. This is a very large file, so chunks of it are moving. As those chunks move, 2, 3, 4, 5, 6, 7, 16. The full file is now on that hot tier. 1,100 IOPS. Now we're up to 20,000 IOPS with 4 SSDs. And to combine it even further, if I actually went in and had write-back cache on there, again, if there was a problem, something happened, it would simply absorb it, and everything would keep on going. You keep on going with your IOPS. The first question, I hope it's an easy one.
I just wanted to ask, in regards to setting up your RAID redundancy for your disks, what happens with your tiered storage? When you, so for instance, you've got your slow disks and then you put your tiered SSDs. When you're choosing your redundancy, whether it be mirrored or the parity, what happens? Is it, can you choose different parities across the different tiers?
To repeat that very long question, because I'm sure none of you heard that at all. Basically, what happens to your data on that redundancy when you go in and you add the disks? And how does it basically rebalance itself and sort of stuff is kind of what you're talking about. You basically have to remove a disk It's easier just to, if you have the capacity, add in SSDs and add them into the pool. But you have to basically remove the disk. Everything settles out, put the new disk in, and then add in the rebuild to be able to handle it. And then it basically detects that there's a new one. You go off and make a space, and it's now protected and good for the tier. Ideally, what's going to happen is you're going to have to end up going in and making a new pool and then simply moving the data over. Ideally, you do your tiering when you make the pool and it's done. One thing that's important is if you already have 2012 in place right now, you are able to simply take those disks, attach it up to a 2012 R2 server, take ownership of that particular storage space because the metadata is stored with the server, sorry, with the drives, and it basically can now pick up where it left off, and it now is a 2012 box. For the first question of the day, I'll give you a big one. 2 ounces, pure gold. Now, that was one demo that was there. I want to show you this next part. If I flip over here to number 1. We've already seen this slide. Basically, this is the 2012 environment. You have the same capabilities, but you do not have the tiering capabilities. By simply going in and replacing your servers with 2012 R2, you can now go over and take over those spaces, and then go up and you now have access to them on server 2012. The file server cluster configuration basically allows you to have some optimized capacity for your systems, very, very cost efficient, your best dollars per value for a file server cluster. Or you had a choice between optimized performance with extreme performance, better throughput, and with high IOPS. Now with the tiering concept, you have the ability to go through and have both a mixture of high capacity HDDs and high performance SSDs or their equivalent from different manufacturers to get your best IOPS. When you're doing this, when I'm talking about commodity hardware, at least it has to be spaces compliant. It needs to be basically blessed by the Microsoft hardware catalog as being spaces compliant hardware to get your support on that particular system. The file server cluster solution partners, there's a bunch of them that are out there, obviously. Fujitsu, DataOn, RAID Corporation, even the other manufacturers like HP, Dell, Supermicro, white box suppliers, sort of stuff, they have them. There's a beautiful little sexy device that I just saw at TechEd North America that's actually called the Dell Vertex. The Dell Vertex is a 4-node all-in-one box. I tried to take it with me, but it weighs about 100 kilos. Trying to carry that many drives is a little difficult through carry-on luggage allowances. But that particular one is very, very cool, but they use a hardware-based solution. They don't use spaces to be able to get their data redundancy and that sort of stuff, so they don't have tiering. Other ones by Fujitsu and by DataOn, as an example, they use the option. Do you want to have it with spaces, or do you want to have it with hardware, like the LSI Synchro, as an example? Now, here's my special, I realize my slides are in the wrong order, so I gotta give you the thing. So I will warn you right now that if you're still fuzzy from last night, hang on to your seats, focus your eyes, Dutchie, take a drink of water or something, you're all set. I wanna show you this thing, bonus material. So I wanna show you how to build your own storage tiering demonstration on commodity hardware. What's commodity hardware? Jeff gave me a very cool external drive enclosure that is USB 3 with a 7,200 RPM disk, probably from Dick Smith's. I don't know where he got it from. But we don't have this, it's toolless. You literally just open this thing and slide it out, and you got your drive into it, you pop it in, it's all good. So that's my commodity spindle. And then in here, I've got a commodity SSD drive, and there's my 2 tiers of data on a laptop, just to be able to demo this and improve it. Before I show you how I did this, my session is now a 500 level session because I'm showing you code on the screen and your IT pros. This is part of what's involved to get done. So basically, let me walk you through a little bit of the script. I'm going to show you how to do this. So what I did last night, when I literally built this demo last night for you guys to see it after talking with Jeff, I've got 4 VHDX files, and they're physically located in virtualization on the SSD drive. So that's why my path to D is D/VHD. That's an SSD drive. I've got HVHDX files that are located on my spindle right here, which is the F drive. So I now have 2 different speed drives I can now run my data things against. I will first of all caveat this by saying This configuration is absolutely 100% not supported if you call Microsoft. This is for you to see how this thing works and understand how it works inside your classes, your lab environments, and inside your fun area that you have inside your parents' house in the basement or something like that. I don't know. If you want to go off and do it. So there's the commands to basically quickly go off and to make those different drives. It creates a fixed disk size drive. In this case, a 10 terabyte for the SSDs and a 10 gigabyte and a 30 gigabyte drives for your HDDs. It then goes ahead and creates a new virtual machine. You can create a virtual machine with one line of PowerShell. That's just awesome. That happens to have a pre-made sys-prepped VHD disk. And then you simply add those guys into that configuration through SCSI. Now, because it took over an hour to create over 240 and carry the 1 and 3 and 4 makes 300 gigs of data, fixed drives, I decided to do that last night. So I'm going to save you having to watch that for 30 minutes. And I've got this over here. This is on my laptop. I have my HDDs on my external spindle. I have my SDDs on my, I said SDDs, by the way, SSDs, on my VHD that happens to be my internal drive, which is SSD. Those guys are created. I then have my PowerShell that's running. That basically is what I just showed you on the screen. I already created the machine, but what I will do is I'm going to go in here, and I'm going to add those disks into my virtual machine. And it didn't work. Dum, dum, dum. Did I already add them in? F, it's there. Is my F, did I disconnect my drive? No, he's there. He's got that. He's got that. DC controller type SCSI. Yeah, that's that. What did I do wrong already? What? Machine's called DC. Why do I have this guy? They're there, they're there, they're there. My F drive is there. The problem is I disconnected my hard drive as a demo and back in again. The virtual machine definitely is stopped. He is now off. Let's go in and apply this guy. He's been done. He is available. He's on the S drive. There's my storage adapter. There he is. He's good. You know what? Let's do it this way. I'll use PowerShell on the inside. I can do it this way too. Browse, bring it down to my, this is my SSDs. Let's just keep this. Go in, add a second one. And then add a third one. And add another one. This was so much more impactful when my PowerShell script just ran, but I'll do it this way. There's 4 added. Now for my HDDs, they're on my F drive. There's the first guy. At least copy and paste working. Two. Three. You guys are very patient. I appreciate this. You guys are all watching for typos because you want this demo to work, right? 4. I'm glad I got Adam Birchall right in the front there, just in case there's a typo with group policy, but I'm not using group policy. And then 5. And then 6. Almost there. And then 7. This is what happens when you add in a demo unplanned the night before. It's my thing I always say to people they should never do. Oh, I can do that, no problem. Okay, pretend that was PowerShell. And the machine started. There you go. Much easier with 2 lines, thank you. Demo's now over. Okay. Now we jump inside the actual machine itself. This is just a 2012 R2 preview build. Again, you can go off and download that now. There is a command inside that PowerShell script that, again, makes those drives for you ahead of time. Just make sure you put them on the proper spot. Don't add them and then remove them and then reset the machine and then add them and then remove them and then disconnect the drive and power your system down and bring it to a TechEd presentation, because apparently that doesn't work. When he spins up, what I've done is I basically copied that PowerShell script into the local machine. Don't worry, I know the password. Okay. So, inside Server Manager. Let's see what this guy looks like. File and storage services, under storage pools, I should see my primordial disk. And inside my primordial disks, I will now see all of those drives that I added. Yay, they're all there. I've got both the 10s and the 30s. Basically, the smaller ones are mimicking my SSDs. My 30s are mimicking my HDDs. That's all good. Inside my scripts, I got my TechEd lab demo. I'm going to edit that so you guys can see it on the screen. Okay, so I've already done these first pages. I've created them. I've created a machine. I've added them in, and I've started the machine. So there we go. So if I go in here and basically say, let's go in and just see what everything looks like. I can see that basically I have my disks that are all available. You'll notice right here, if I move this up so you can see this a little bit more, because it's a bit tough right there. Can pool, true or false? True means it's already being used by the operating system and is not eligible. False means it's literally raw disk to be able to be used. So these guys in this case, those new drives I added, they're all true. They're all set to go. And if I want to go off and just list the individual small size disks, watch what I can do here. I can go in here and say get physical disk, but then go ahead, that's able to be pooled, but make sure that the size is less than 20 gigabytes. Sort by the size and auto size that guy on the screen. So there we go. I've got 4 physical disks that can be done that are currently 10 gig. If I go in and choose the large ones, I've got my 8 ones that are large. That's all good. Now the trick that you need to do is you have to go in and set these guys as a media type. But the media type environment is not visible until after you create a pool. So this command basically is going to go in and say, use the storage space subsystem and go ahead and create a new pool. And when that's done, go ahead and identify the fact that I need to change the media type. So here we go, hit F8. It's going to go ahead and basically make me a pool. And you can see here that I now have pool number 1. It's operationally okay. It's no longer in the primordial pool, and it is not read-only. So basically, it's all set to go. If I was doing this through the GUI, and I do a refresh, I basically have one pool called pool 1. There we go. I've got no disks available, and I have no virtual disks or volumes or anything set up to go. Next, I want to go in basically and say, okay, I have to now change the media type equals SSD. We only differentiate between SSD and HDD, which is a media type property that you can go off and alter once they're inside of a pool. Not supported in a production environment to go and do this. Everyone repeat after me. Not supported. There's the first one. So all the smaller disks, go ahead and set the media type of SSD. All the larger disks, go in and set the media type as HDD. Pretty simple. Let's go in and double check to see what this is configured as. Well, I can still see I got my pool. They're all good. And I can sort my disks by size. And it comes up and it says, okay, look at this. I have both my total capacity's gone down because the space has to be, data has to be involved in it. I can see all my drives that are available. But then here I can go in and say, list me off my media type this time. So I can see here, I have my SSDs are the small guys, and my HDDs. If they come up as unknown or unavailable, then basically you didn't do it right yet. Okay, here's my tiers. This is normally just one ticky box inside the wizard when you're making this. So I'm going to say, go ahead and make me a new storage tier called SSD tier and include the media type SSD. Done. Go ahead and do the same thing and make it for HDD tier. Done. And then let's go ahead and see how this looks for a tiering perspective. Do I have both tiers made? And the answer is yes. I've got a tier called HDD and SDD tiers. Also good. I don't think I've lost anyone yet, but you might be sleeping. Next up, okay, what are you going to protect your data with? Let's lay this down to protect our data across the thing. I'm going to make one that's going to be called simple for protection level, and it's going to be using 4 columns. And I'm going to be using one that's set up as a mirror, which is going to be using 2 columns. Columns is basically the way that you're grouping your disks together to be able to write your data across your different drives. Columns generally need to be divisible by the number of drives that you happen to be using. It has to be equal numbers. And it can affect your performance if you have the wrong number of columns. Basically, fewer columns, more drives gives you better throughput. There's the first guy. There's the second guy. Now, the interesting thing is, I like to flip back and forth here. Back on this side, and do a refresh. For the traditional tool, it still looks the exact same, because you're not done that wizard equivalent as of yet. So then we go in finally here and say, okay, let's go ahead and actually create these spaces now. There's the first one, and there's the second one. Going back over here, hitting the refresh. Do I have it yet? Do I have it yet? Not yet. Almost there. Last part is partitions and volumes. Now this is a little trick. I learned this last night the hard time when you guys were off enjoying the roller coasters. Don't highlight this entire block of text and say execute at the exact same time, because it doesn't have time to finish, and this gives you error messages on the screen. Remember that. So there's the first one. Go ahead and basically make sure that the space for disk happens to be available and is not read-only. Go ahead and say, make sure it's not offline. Set it up to say, initialize it with a partition. Set it up and create that new partition, assign it a drive letter F, use the maximum available space. And finally, format. And because you don't want me to say that again, I'll just do it quickly here. So what I'm doing basically is I've made 2 different spaces, one of them in a mirror configuration and one of them in a parity configuration. There we go. Now, this is probably going to look a bit more familiar to you when I go and take a look at this. I now have my virtual disks laid out. I've got space number 1, space number 2. Space number 2 is set up with a mirrored setup, and space number 1 is a simple. Sorry, not parity, it's a simple. So basically just striping of data that goes across. Now here's the part that I really found interesting, because I'm a geek like this, is how do I prove that any kind of load is happening on these disks that I can then go off and show you guys? Well, first off, if you go ahead and create some data files on your system, I want to make 3 data files that are on the system. File number 1, file number 2, file number 3. And I'm going to go ahead and make sure that I tell them, let's put file number 1 on the SSD tier. Let's put file number 2 on the HDD tier. And let's go ahead and ensure that we've got a nice drive letter assigned and everything, which is good. So you can see here, file number 1 is sitting on the HDD, so the SSD, and one of them is on the HDD tier, and it's only partially there. Do the same thing for the G drive. And the first one, put them in. Second one, put them on, and get them going with that. So, what is the end result? I now have both my guys happy. I've got some guys partially on the different tiers, which is normal because the data is waiting to happen for 1 a.m. to be able to do it. So let's actually go and manually kick these guys off and see what tasks are involved in case you guys are interested. So the first one is here to go ahead and basically tell you that there's an optimization one that goes, and then there's a management initialization task that has to run. Optimization is where it actually does the move. The management task does the analysis. And the analysis is going to basically tell us, hey, this bloke over here has asked that these drives get pinned, these files get pinned on those different systems. So the first one is start the scheduled task to go ahead and to do that move for me, please. And then the second one is actually go ahead and see if it's finished yet. You can't see this, and I'm pretty sure the camera can't zoom in on this. I'm going to totally blow up my demo because I'm changing. See the blinky light there? I've got this gyroscopic motion of a 7,200 RPM drive going on right now, and I'm terrified I'm going to move this too fast and make the head slam into the platters. So that guy now is basically moving all the data. I need to fill some airtime for about 3 minutes as it finishes the move. But ideally, as a bit of a recap, what I've done is I've pre-created the VHDs to sit on the hypervisor level on the physical different types of media. Inside the VM guess it has no idea it's on different types. I then went in and faked it out and told it, this is really SSD and this is really HDD, and it now knows that, therefore the tiering options become available. If all you want to do is show that you can turn on a ticky box that says tiering, that's all you have to do. If you want to actually prove that stuff is going on, you got to do this last part, which is basically moving those files off and then running some SQL I/O against this. And at this point, because my blinky light is still going, yes, sir.
You said the optimization kicks off at 1 o'clock in the morning, or you can manually do it.
Right.
Could you tie something into Perfmon alerts to say if it raises to a certain level, kick off the optimization now?
Good question. Basically, you're able to go in and say proactively, if certain types of activities happen, can you go off and kick it off? I'm going to say I don't believe it's granular enough for the scheduled tasks to be able to do it. It's using the system scheduler, system task scheduler. I know you can get pretty complex with what it's looking for, but unless you're going off and using something more advanced, it's not going to be able to know that there's stuff waiting. So you can say on log on every hour, every Tuesday of the month, whenever Rick logs on or something like that. It can run it if you wanted to.
I'm thinking within a classroom situation.
Yeah.
When we're kicking off the VHD, I want to hit the server and say, start optimizing now.
Yeah, if you're inside the classroom environment, you want to go off and try this, the best thing to do is just use those 4 PowerShell commands that I gave you. It's glass, so I don't want to throw it too far. There you go. Yes, sir.
Could you basically replicate this demo on like your current SAN, for example?
Great stuff. The question is, can you just replicate this on your current SAN? The answer is absolutely yes. If you don't know how many IOs per second you're getting out of your SAN, you probably should figure that out. But if you want to try to replicate this on your current SAN, you can, because it's just a hypervisor talking to a LUN, basically. My LUNs happen to be direct attached. And my blinking is done. I have less than 4 minutes. I got to hold off on the questions because I got to show you the coolest part, which is going off and running SQL I/O. So SQL I/O is going to go in here and basically just, okay, let's do this first one against volume F. So in volume F, they are both completely on the tiers they're supposed to be on, so I will have some differentiated numbers that I'm going to be going on. And the first one I want to go off and run is basically a SQL I/O command going to be doing some random testing in 8K chunks across those files. It's going to run for 30 seconds, and it's going to come back with a number at the very end, when it's done running, to report. I have to fill 30 seconds of airtime. I would like to actually show this to you across both of them. You can actually see the differences between a simple space with no protection and a mirrored space, and you basically would see that it's almost negligible, the difference between the two of them. It's a little slower on the mirrored one because it has to know where to go. There we go. I've got 4,835 IOPS per second on this stupid little laptop with external drive configuration. That's off of the SSD. If I do the exact same one again, but then I choose file number 2, and F8, 30 seconds of airtime once again.
This is all available,
This is,
scripts and that we can get off here?
so the question is this all available off the scripts you can do? And the answer is yes. I put all the scripts as 9 slides chunked up by what they're doing. Inside the PowerPoint deck, they'll be available for download within 24 to 48 hours of this session. And at the top of the script, I also reference the blog post. I can't take credit for writing these scripts. This was written by Jose Barreto from the file server team. He had a phenomenal blog post. Look at the difference in performance here. We had 4,000 and change IOPS off of my Dick Smith's special hard drive. I only got 110 IOPS off of that spindle drive. Pardon me? This is not fully supported. In the interest of time, trust me that I would get similar performance if I ran it off of the G drive as well. I think personally that's one of the coolest things that you could get here at TechEd is the ability to recreate this demo on your own hardware, on your own laptops and SANs, and I give it to you. There you go. Please remember that with the evals, 5 is good, 1 is bad. We need to have the evals, right? So here it is, just to take a look at the scripts in case you're interested. You got validate the disks, make sure the media type's been set, configure your tiers, making the spaces, making the partition, test your files. So just trust me, they're all there. I'm going to jump to the last part for my takeaways, which are basically 2 things I want to make sure you guys are leaving with. Server 2012 R2 is an absolutely critical key component to your public and private cloud deployments. Enterprise-grade state capabilities of storage, easy to expand, cheap to manage, cheap to acquire, phenomenal performance increases with very simply adding in some SSDs into your drives. Customers have gotten 2 times, 3 times, 5 times different levels of performance increases. You've seen it here today on my cluster in a box from data on, going from 1,100 IOPS up to 20,000 IOPS, or sorry, 1,000 IOPS up to 20,000 IOPS. Amazing stuff. And significantly reduced craziness to go off and to manage them yourself. With that, I'm going to say, wow, you guys are phenomenal. I have 30 seconds left, and so I'm just going to give you the last one, which is a reminder. Please be nice, fill out your evals. Very important to come back and to tell us at TechEd Organizing how to do things better. Tweet to the hashtag, which was WDC311, if you have any questions. MDC, thank you, 311. I'm here all week. The week's over. I'm here the rest of the day. You're welcome to track me down. I always wear the hat. I'll be in the Tech Expo Hall if you have any additional questions. And with that, adieu.